Hello students, welcome to this video. In this video, we are going to learn how to solve systems of equations algebraically, which is lesson 8 on page 243 from the book, from the first volume of the book. Okay, this is an important lesson and we have to understand it. It is one of the most important lessons in this course. Let's start by example 1 on page 244. Last time in the previous videos and previous lessons, we have learned how to solve a system of equations by graphing. So if we have two equations like these two here, okay, we graph the line for the first one. We just have a y-axis here and the x-axis. Okay, so what we have been basically do is to graph the line for the first equation, take this equation and graph a line that represents it. Let's say it's something like this, okay? And then we took the other equation and graph the line that represents it. It's something like this. At this point, the solution for this system of equation is the intersection point here. We just found that point and say that the solution of this system is something in x coordinate and y coordinate, something like that, okay? This is called solve systems of equations by graphing. This method is graphing. Now, we are going to introduce a new method which is to solve this system without graphing, or we can say algebraically, which means without using graphs to represent the equation. How can we do that? Okay, each time we are given a system of equation, we have a different value for the variables. Let's see for y here. How much is y? We can see here. Okay, here we can see that we have two values for y. Two values, not numerical values, not numbers. They are equations. We have here an equation that represents y, which is x minus 3. So we can say that y here equals x minus 3. And from the other equation, we can see also that y also equals 2 times x. Okay? That's the basic idea of understanding this lesson. We can see and move on the questions. All of the questions we are given values for y. In this question here, we have two values for y. The first value is x plus 4, and the other one is y equals 2. We only need one value to be given, like this question here. Um, let's take this equation here. Yeah, in this equation, we can see how much is y here. It is equal to 3x plus 8. The second equation doesn't give us a straight a straight value for y, but the first one does that. Okay, so we are only need just a single value for y to solve these equations. Okay, let's back and solve these examples one by one. Let's start by example 1 on page 244. We have two equations here, and this is called a system of equations because they share, of course, they share the same variables. We have y and x, so it's a system of equations. To solve the system of equations, we are going to use the method substitution, which means we need to pick up a value for y. Here we can see that y equals let's see it from the second equation. The second equation gives us that y equals 2 times x. We are going to use this value in our solution. How we are going to do that? To do so, now this is the value for y. So we're going to take this value and substitute it in the other equation. And it's the first equation here. And instead of writing y in the first equation, we are going to put how much? 2 times x. We are going to substitute the value for y in the second equation into the value for y of the first equation. That's why it is called a substitution. Let's see how can we do that. The first step is to rewrite the other equation. We have the second equation tells us the value for y, so we are going to rewrite the first equation. Okay, which is y equals x minus 3. Do we know the value for x here? No, but we do know the value for y now. How much is y in this equation? We can see that the second equation here gives us the value for y. It gives us that y equals how much? How much? It's 2 times x. So we need now to rewrite the equation again, the second equation, but this time instead of writing y, what should we write here? Instead of writing y, we need to write 2 times x. 2 times x. Why we did that? Because y is equal to 2 times x. How did we know that? From the second equation. And which equation we have wrote? The first equation. So basically, again, for the last time, we take the value from one of these equations for a variable and substitute it in the other equation. Okay, so here what we are left with, let's just continue the equation as it is. 2 times x, which is equal to y, equal signs remains, and x minus 3 remains the same, x minus 3. Now, this equation here is one of the forms of equations that we have learned how to solve last semester. It's called an equation with variable on each side. We can see here that we have an x variable on the first side and an x variable on the other side. Okay, how do we solve these types of equations? We simply move one of these two variables, and we prefer the variable with lower coefficients, but of course we can use them both. But let's here move the x, this x here. Its coefficient is 1, so that's why it's not written. So how can we move it to the other part? It's a positive 1, so we need to subtract it from this part. Are we done yet here? No, not yet. We need to subtract the other side of the equation as well. Okay, for this side here, what we are left with, 2x minus x, how much is that? It's 1 times x, which we can just represent as a single x again, alone. Okay, what about this part here? X minus x, how much is that? It is, of course, 0. So what we are left with for these equations here, we have x on the first side to the left, like this, x equals 0 minus 3, or we can say nothing minus 3, which is actually minus 3 alone. So we found the value for x, and that's the first thing to solve this system. We have now the value for x. Okay, that's great. How can we find the value for y now? How can we find the value for y? We know actually the value for y, not the value, the equation that y. Y is equal to how much? It's equal to 2 times x. So we need to take this value here and substitute it here. Okay, so we can get the answer. Or we can substitute it also in this equation here, and both of them will give us the same answer. Okay, so let's try them together. Let's try them both. The first, I will just take the first one here. Let's substitute x. Let's substitute x in the second equation. This equation here. Let's rewrite the equation first. Y equals 2 times x. Okay, and now instead of writing x, what should we write? Substitute its value. We know now that x is equal to negative 3. So the answer will be something like 2 times negative 3, which is equal to how much? Y is equal to negative 6. And that's it. We solved the question. But let's say that a student just want to substitute in the first equation, not in the second one. Okay? How can he do that, or she? Just you can rewrite the first equation. The first equation is y equals x minus 3. Okay, and now instead of writing x, we know the value for x now. We know that x is equal to -3. So we can substitute that and find y equals, instead of writing x, what should we write? -3. -3 minus 3. And how much is this? -3 minus 3 is equal to -6. So they are the same value. So you can just do this one here or substitute in the second equation. Doesn't matter. Okay. Now, how can we represent the final answer of this system? How can we represent the final answer for this question? Okay, when we solve the questions graphically, we just take the intersection point and find its coordinate. Okay, so here is the same process. We open two parentheses for the coordinates, and the x coordinates, how much is it? It's -3, and the y coordinate, it's -6. What does this point represent? It represents the intersection point between the graph of the first equation and the graph of the second equation. So the answer will be just something like that. We can write the full answer for this question as this: -3 and 6. Okay.